All right, to start off, we had a question about when to use concat versus join versus merge in pandas. Short answer to that is concat is typically used when you have, when you literally just want to stick to data frames together. So by that, I mean, let's say you're collecting data and you've collected all 2020 data. In the future, you collect 2021 data. You would just concat them together, put them, literally stack them on top of each other, and that's where you would use concat. Very likely, the most common, one of the more common cases you would use that is like maybe you have data for different states, and different states happen to be in different CSVs, and you just want to stick them together, you would just use a pd.concat. Also, if you happen to have, this is a little rarer, but if you happen to have different data for the same thing, so let's say you have one CSV that has like demographic data of a state, and then one CSV that has like maybe voting data on a state. And you have like the two CSVs separately, you can concat them sideways as well. So concat is literally when you want to like stick two data frames together. It doesn't really match on anything. So it doesn't match like on index, it doesn't match on any columns. You're just really, if the data frames are of the same shape, depending, no matter what axis, I think the default is you'll just add more rows to your data frame, but if you do axis equals to 1, you're putting two tables side by side. That's like a rougher way of joining. Versus the other two methods of join and merge, they're quite interchangeable. Join and merge are quite interchangeable. It just depends on which one you prefer using. I will say that I end up using pd.merge more, because merge, actually, if I look up the documentation of both, actually, let's do that. And there is, where is it here? Pandas join and pandas merge. I like, oh wait, that's join. I like merge better because merge actually takes in the two data, does it take in, or it allows you to take in the two data frames? No, wait, let me confirm this. They take in, they both, you can do the same thing with either join or merge, but they just use arguments slightly differently. Like here you can see you give it one data frame, you can join it on another data frame, and you have the how and the suffix. I think this actually might be very, very common. With the merge, you have start with a data frame, give it another one, tell it how, on what. Oh, and this one I think where merge is more specific. Yeah, merge is more specific because let's say you have different columns and different column names. You can say, all right, I want to join it left on this specific column and then right on this specific column. So merge, you can be a little bit more specific with what you're doing. So I think, yeah, because of that, I actually use merge more than join. But they pretty much do the same things. It's just that with join, you might have to, you might end up having to turn a specific column into an index before you join. So pd.join uses the indexes to join more by default. Actually, I think this might be by default as well. But basically with merge, you have more options for more specific joining. Hopefully that that clears it up. Concat is more like literally just like sticking two data frames side by side or top and bottom. And then join is join and merge, pretty interchangeable. They just have like slightly different abilities. And merge, you have more arguments that you can feed it in to get more specific joins. Cool. Ali also had a question about this planets database. I believe this might be an error, but I'm not too sure. So you basically start off with this table that you're querying, and I believe what we're looking for is we're looking for planets with rings, right? Yeah, planets that don't have rings, and then we're going to order by. And here they're saying rings equals to 0, where here rings was actually no and yes. So I think this might be an error on this table. In case any of you run into this, I think this table might be incorrect. because, yeah, because here we're selecting everything. We're also selecting everything from here, and the rings is 0 and 1. So I think the schema here is basically incorrect. I believe it is 0 and 1. But I would say just play around with it a little bit to make sure. But if they're using this code in the solution, that makes sense, where rings equals to 0. I'm pretty sure the actual table has maybe 0 and 1 values. Does that make sense? And before I start on topic 8, any other questions? All right, okay, so let's get started with topic 8. Let me close these out so I'm not distracted. All right, as I mentioned, topic 8, pretty optional, just because very unlikely we'd be using this. In topic 8, we are actually looking at this database type called MongoDB. And there are many other database types that support this database type. Basically, it's a database that is not in a table format, it's in a document format, and MongoDB is just one of many technologies that you can use this kind of data with, which is why it really kind of depends on like what company you go to and what kind of database they are already using. And because there's so many out there, you may or may not end up using Mongo. I think out of all my students, only one of them has ended up, or that I know of, uses Mongo, and she actually works for MongoDB. So that's just a little bit of context, but it is good to know. You might end up maybe for your capstone project using a big set of data that doesn't fit into tables or data frames. You might look into MongoDB. So let's just get started. A lot of this is copied from the lessons. So I'll just go through some of the main points. So whereas for SQL, we were looking at table formats, here we're looking at document stores. So a document store is a database that stores records as unique documents in a database. This all you can read. Basically, in each document store, you have documents that contain key value pairs. And key value pairs should sound kind of familiar because key value pairs are dictionary formats in Python. So basically, if you have data that comes in a dictionary format, and actually tomorrow we'll take a look at where you will end up getting big chunks of data in a dictionary format, where this kind of database might be more useful. So yeah, you have the actual data being stored as values, and you have keys as well. And I'll also run through a couple examples. MongoDB, I will say when you're working on these labs, to get these labs specifically to work, you have to work on them locally. Because you will be creating a database on your local machine, which is why you have to do this locally. And a couple steps you have to do. Unfortunately, depending on your operating system, there is a slightly different installation process. I believe on the lessons, it does walk you through, I think, one overview, one for Windows, one for Mac, and one for the newer Macs. So if you ever run into issues, if you decide to work on this topic, if you have issues, just let me know. I do have a few resources here and there that have been used to debug any installation issues. So as I mentioned, you're actually going to be spinning up your own local MongoDB server. We basically will go through these installation steps. These are the installation steps for not even my version of a Mac OS, but these are, I think, the older Mac OSs. These will be the commands. So depending on your OS, this may or may not work. Also, this mongod command is also specific to a specific kind of Mac. So this very likely doesn't work for you unless you have a Mac that's about like 3-4 years old, just to let y'all know. But this is, I think, what's in the lessons. I believe there are more instructions, but as I said, Mongo is really, really hard to set up. If you need help setting up, we can talk about it during a one-on-one. But basically, once you've installed MongoDB, I'll walk through how on my computer I start running the server. The commands will be different for your computer. I think most of you guys actually use Windows computers, so I apologize. But I will look for a resource for Windows and then set it out to the class. All right, we can see my terminal window as well. Cool. All right. So to start MongoDB, on my computer specifically, I actually use Homebrew. Homebrew might sound familiar from when you're setting up your environment, and Brew is actually how I installed MongoDB. And if you also have a Mac Catalina or later, that's how you would install MongoDB. So to start, you actually have to run MongoDB from Homebrew. So everyone kind of has a step similar to this, but not this exact command. So for mine, it would be brew services, because MongoDB is a service from Homebrew. Run MongoDB community. And you can see something is running. So I've started to run my MongoDB server. You can also see if you're using Homebrew, and I think Windows can also work with Homebrew. So you might end up doing this as well. But if we take a look at all the brew services that we have, we just do that by doing brew services. You'll see here that I started this MongoDB server. Let me make this a little bigger for y'all. A little bit bigger. All right. Finally, this is not already starting the DB server. This is just starting up, I guess like a pre-startup to starting up the server. But then you just type in Mongo and you have this shell here. If you end up, coding a lot with these MongoDB databases, this is not part of our program, but you'll be able to actually like type in commands here and like do things in your Mongo's database server. However, very similar to what we were doing with SQL, we can actually interact with this from our Jupyter notebook, which is what we're gonna do instead. Because honestly, I don't really know those terminal commands either. But okay, with SQL, we had our SQL cursor that we used to, we used our like read SQL pandas function so that we could easily extract our the results of our SQL query into pandas. Very similarly here, we have PyMongo, and PyMongo is a library that has what's very similar to the cursor object that we were working with in SQL. So here we're going to use PyMongo. These lines we're actually talking about tomorrow and Thursday. You'll see a little bit because I'm doing a little bit of web scraping here, but we'll get into web scraping on Thursday. And requests we'll also talk about when we get to topic 9. So don't worry about, I'll say when there is code to not worry about, but these are what those libraries are for. So let's import. We start with PyMongo. And then here we're creating the client. We're running up our local database. So these numbers mean that's local, I think. But basically it's starting up that Mongo server. Sorry, the Mongo server is already started up, but it's connecting to our Mongo server. So this has to be running in the background. This must be running in the background, very similar to how, when you're running a Jupyter notebook, you have all of this stuff going on. So you can't really use you can't use this terminal window. Very similarly, if you're using Mongo, this has to be running. So let's connect to Mongo here. Then if we print this, we can see that these are databases. These 3 exist by default. This last one is actually what we're going to be creating, but I've already created it, so it's already there. So this is what we'll be creating in this lesson, but these exist by default. So these are the databases that exist on your Mongo server. Questions so far? All right, cool. This is a topic 10 preview. All I'm doing is I'm actually gonna web scrape really quickly, web scrape this website to use as our data to put into our Mongo server. And I'll actually talk about this in scraping on Thursday. So let's ignore this for now, but what we know is I have a library, not a library, I have a list of dictionaries, and this is what I'm gonna put into Mongo. So yeah, we're gonna be working off this list of dictionaries. So you can see these are quotes. I think each dictionary has a quote key that has the exact quote and an author key with the author. All right, so let's create the database and insert the data into Mongo. It's pretty much one-liners for each. Here, very similar to how we create a new key in a dictionary. We create the database, quote database, and within the database, we can create a collection. And I'm going to call this my collection. And when we list database names, earlier, if I didn't have this, this would now show up. This is another line that if something goes wrong later on, we can actually reset the database. We'll talk about these like delete statements in a little bit as well. All right.
Excuse me.
Yes.
I was wondering if you could change the size of your browser to full size, please.
Oh, absolutely. Yeah. Yeah. Thank you for pointing that out. We don't need the terminal anymore anyways. This is good?
Yes, thank you.
All right. Okay, so we've created our database. I want to backtrack a little bit and talk about if you decide that you enjoy working a lot with databases, what are some of the skills that interviewers look for? So let's backtrack a little bit and talk about CRUD processes. So here we have CRUD processes. You might see the acronym CRUD appear on job applications or job listings. So if you feel like you like databases, you might want to learn a few of them and make sure that for each of the databases, you know how to do CRUD, which is basically creating data or creating your database and creating documents in your database, reading data. So just like very similar to querying, updating data if you want to change something, and also deleting. So we'll actually walk through these with MongoDB. You'll find that with a lot of these like third-party like database softwares, it's just a new set of commands that you have to learn, but they all have very similar functionality. Not all of them are as intuitive, but just so you know, each of these database softwares has their own version of CRUD, very likely. All right, let's get back to this. So we created the database and our collection, and I just like made sure that mine was empty just in case I didn't empty it from last time. Okay, so what we're gonna do here is we're gonna insert all of our quotes, and you'll see it's actually pretty simple. It's just a single line of inserting all my quotes. So my collection, which is where the quotes will live, which is what I created up here, has a method, insert many, and I literally just feed it in my list of dictionaries here. Let's take a look. All right, so I have inserted this. Let's take a look at the database names again. And let's take a look at what I had inserted. So this insert action, I had assigned it to a variable just so I can see these things. So typically, if you don't care about all of these IDs, you don't have to assign this to a variable, but I wanted to assign this action to a variable just so I can inspect what I did. So that's why I'm doing this. So from results, I'm just taking a look at what I've inserted, which is awesome. Here you can see that I've inserted, I think this is 10 quotes. Questions so far? All right, so that's the first one. That's just creating and the C of our CRUD. There are different ways to do it. You can insert one by one, but typically if you already have a list of dictionaries or data that you've retrieved from somewhere else and is already ready to put in this database, very likely you'll use insert many. All right, now querying. For querying, pretty simple. It's just .find. Very simple that way, .find. Let's take a look at what these are. All right, so you can sort of see here that we have a cursor object, which I mean, we were using the PyMongo cursor to interact with our database. So something is here, but the way we actually look for this thing is very similarly, we're gonna actually assign the action to a variable so we can take a look at the results. So query, we're gonna assign this find statement, and then we're gonna run a for loop just to print everything within query. So it's not very obvious, but query is this cursor currently that is an iterable object. And if we run this real quick, you can see here, it automatically creates an ID, which is good. And we have our, I think this is 3 quotes from Albert Einstein, because we basically looked up using a key and value pair. And that's how we look for Albert Einstein. Cool. Very similarly, we can search for any author. Let's see who else is in here. We have Steve Martin's in here. So let's just see if this works for someone else. Steve Martin. And there we go. We have the objects. So very, very convenient way to look up things in a dictionary formatted database. All right. So that's the C and the R of CRUD. Now the U, updating data. So updating data to Mongo, also a one-liner. Let's take a look at this. So imagine that in a big database of like quotes, and let me see if I still have, that website up. I do not. So imagine in this website, you have these tags. So let's say you wanted to look up something by tags. We can do that as well. But currently, our Mongo database doesn't have tags associated. So how will we go about adding tags? Let's take a look. Back to updating. Here we go. So let's start with just a simple example. We just want to add these tags to Steve Martin's quote. So let's start with this. Steve tags is going to be this list of tags that we're going to store in this dictionary. And then next, you actually have to do which subset of data to update and also what new data to add. So this syntax is a little bit confusing, but you first start by assigning to a variable what subset of data you want to update, because this is going to go into the update command. So kind of three parts here. We have this actual update command that we're updating Steve Martin's entry in the database with the tags. So here we see that this is what we're updating with quote tags to be Steve tags. This is just the syntax for how you add a new key to the dictionary. So you can see here, we're adding this new key to the dictionary of quote tags that will have the value of Steve tags. Few pieces to the puzzle here, but when we run this, you can see that there's a result here. And then now when we query for Steve Martin, we'll see that now he has quote tags. So that's just updating entries into data in a database, in this database. There is also a update many. Looking at the documentation, it actually works very similarly. It's just you would update if this result gave multiple, maybe Steve Martin had multiple quotes, then if you did update many, it would update all of Steve Martin quotes with these tags. Questions?
I'm getting confused between database and collection.
Yeah.
Especially since you called it my collection. Is that really a collection or is that a database?
Yeah, that's a really, really good clarification. So technically, yes, we are actually updating the collection. That's my bad. But yes, collection is a subset of database. So I should be saying collection. Thank you for clarifying. But yes, we are actually updating the collection. All right, now last part of our CRUD process, and you'll see this is actually the end of our notebook. We can also delete data from Mongo. So there's delete one, and there's also delete many. So for most of these, there's one and many. But here, let's just delete one of Albert Einstein's quotes. And what this does is it actually just looks for the first one to delete. So let's take a look at this. And you can see here, I again assigned the action to a variable. And you can actually take a look and see it has an attribute of deleted count, which is one, so deleted one. And now, previously we did an Albert Einstein query up here, or did we change it to Steve Martin? But anyways, there were three entries with Albert Einstein. I think if we look up here, there is this one, and this one. And if we just were to query again, just to check if it was deleted, we are left with 2. And yeah, that's pretty much it. For any database software that you decide to use, these are really the only things you're going to do with it. Creating data, reading it, updating and deleting it, which is why I say this is kind of optional. One, because there are many different database types, like you might not end up using Mongo, but also in an interview, you get more SQL questions. Like I've never seen any interview questions on this topic specifically. But yeah, any overall questions? All right, yeah, so today's study group was a little shorter. I also want to give a preview for the upcoming two, which are actually more important. So the next two topics are JSON and APIs, as well as HTML, CSS, and web scraping. And these are just two methods to get data from the internet. One is some companies actually set up APIs that you can use their data. For example, here you'll be using the Yelp API. Yelp API is actually pretty good. Other companies like Spotify has their own API to get all the information about all the songs. They have a really great one. And so that's one way you can get data. And then in topic 10 is web scraping, which literally any information that you see on a web page, potentially you can use as your data. And so these two topics will be walking through the two different ways you can get data from the internet. I will say, just to clarify on like the topic focuses, for this topic, a lot of these are one, repeated from dictionaries, and two, also just a lot of reading. So working with JSON schemas, you'll actually see that JSON schemas are basically giant dictionaries. And so it should be kind of familiar, just a lot bigger. So if you want more practice with working with dictionaries, just like manipulating stuff with Python, highly recommend going through these again. But if you're comfortable with dictionaries already, you don't really have to. And then we have a bunch of labs here: introduction to APIs, client server model, all of this. I would say like these 5 are more like theory, like server theory. Which, to be honest, not super important, because you wouldn't be asked for that unless you were going for more of a, I guess, again, a more of like a database-centric job. But the more important part for us is using an API, like actually just using an API. So highly recommend, if you feel short in time, just focus on the bottom few. I would say maybe do this like request response cycle lab, and then actually this lab walks you through using the Yelp API. And I will say this one is a really, really good one to be working with somebody, because sometimes APIs can be a little bit finicky. It's just a good idea to pair up. And again, there are a couple groups that I know have asked for me to be a little more hands-on in like the groups and like working. So what I'm gonna do is tomorrow I'm gonna assign pairs within groups to work on this Yelp API. So just a preview for tomorrow. And then you'll be working on this in pairs, and then just show me what you've done during either of your one-on-ones. Sound good? Questions about that? I know it's our first little like homework thing. But yeah, just really want to get you guys used to working in pairs, because the project will be paired. So I think it's better to have experience working with other people before the actual project. So I will be sending out a list of pairs tomorrow before study group. Or actually, no, I'll send one later today so that you can start working on it if you'd like. And finally, with web scraping, if you saw my note on the homeroom page, this first half is all ported over from the software engineering program. It's just a little bit of intro to how HTML and CSS work. I will say not super necessary to go through all of them. They are fun ones because you actually get to make little interactive things on like a web page. So they are fun to do, but not super, super necessary. I think it does help understand with your understanding of HTML. So could be something that you guys work on. But again, I know that like we're kind of jumping around topics for these last few topics of this phase. So if you really want to focus in, I think these bottom few lessons will suffice. Any questions about what's coming up this week? I will also be assigning the project on Friday. along with project pairs. And I will be walking you through on Friday, one, the project expectations, and two, also how to set up your GitHub, and then also some notes for working in GitHub. All right, any questions on anything?
Will you write in the phase 1 which topics within topic 9 and 10 we should focus on?
Yeah, I think I have it on the homeroom here.
Oh, I see. Okay.
But yeah.
Got it. Okay. Thank you.
You're welcome. Let's see. All right, if there's nothing else, I guess we can end a little bit early today. And then I will see you all at your one-on-ones or tomorrow's study group. All right, have a good rest of your day, everybody.
Thank you.
Bye.